So it has got a lot of power in it. If you master the directional well planning, it could be kind of empowering you for a lot of industries, basically. Mainly around the kind of oil and gas, basically. But a lot of geothermal activities are coming on board, and there is a lot of carbon capture well. Anybody had been working in geothermal or oil and gas in this team? Anybody wants to say that they have seen some other uses other than oil and gas for these directional wells? Currently, what is happening, geothermal wells are getting very, very popular as well. And they usually drill them low inclination wells, but some of them are getting deviated like 30 degrees or something like that. And the carbon capture could be any shape of the well. Basically depends upon the reservoir type, reservoir shapes. So it has got a lot of power in it. And that's why we want to call it a master class, basically, because learning just one skill, how to plan the well directionally, you should be able to do a lot of work in various other industries. The main thing is oil and gas industry. And the directional wells are quite directional. When I say quite directional, they could be turning, twisting, building, and dropping in all the shapes and sizes. But for the geothermal, things are quite simple. They usually hold, drop, and just do the small stuff. So I think that could be the really great course. And nobody can learn anything just by becoming a master in the software. What you are looking at on the screen is the software pictures, software, beautiful shape of the wells, and they could be easily designed. The most important part, however, is to actually drill those wells, making those wells happen. Anybody can draw directional well shape, ERD shape, extended reach, and horizontal, and all kind of things that you can actually do. But it is very hard to deliver the well, drill the well, the shape that you really want. That is why this course would be really great in the sense that it will be showing you how to actually check your trajectory. And I will just talk more through the slide pack, basically. Okay, so I'm going to go to the next one. So for this short session, we'll be talking about the introductions, about the topic itself, which we just did actually. And we will be talking about the basic well planning theoretical concept. Why would you want to know theoretical concept if you want to master something? This is exactly what I'm talking about. You need to know what you can or cannot do, what you should and should not do with the well planning and the trajectory designs of the things. And maybe when we are through, we can take about 5 minutes break if you like, or maybe possible or not, I don't know. And also we will look at our trajectory in the context of, can we drill these trajectory? Can we actually find those trajectory easy to drill? Can the software prove that these trajectories are the best trajectories? For example, you have designed a trajectory and you are happy, your bosses are happy. Nobody did any well engineering analysis to check on the trajectory. You have to run analysis, another analysis to evaluate the trajectory. And when you evaluate the trajectory, you want to know if the trajectory is doable. Can you actually construct them? Okay. And lastly, we will talk about the question and comments from the team. If anyone has any question, they can ask. Okay. Just a small introduction. I'm not going to talk too much about myself because this is not a nice thing to do. Yeah, on my end, I have been around for 20 something years, 23 years. Whenever I say I have been around for 23 years in the oil and gas industry, the first thing people say that you are older person, which is 100% correct. I'm a little bit older now, of course. So I have been doing these kind of oil and gas designs and drilling optimization in 2 different domains, that oil and gas as well as geothermals. Okay. More recently, I did the training. It is called Advanced Well Engineering Diploma Training. That was attended by 8 companies representative. There were like 15 young drilling engineers, and all of them have very nice titles. Some of them senior drilling engineers, some of them just drilling engineers. The great thing about it, there was a lot of enthusiasm in that training that I did last year, actually. December last year, it was finished. What we did in the training, we trained them 1.5 hours every day, give them practical work. And it was one day off, like Monday, Wednesday, and Friday. 1.5 hours every time. We meet only for 3 sessions every week for 2.5 months. And these gentlemen and the ladies, they were thrilled with the slow pace of these and learning alongside and using the software to do things. Remember, in the drilling and well design, the softwares are very close to each other. If you become master at one, you used one of them, it's got the input screens and output stuff. It's a similar, there's no complexity in there. If you become master in one software, you will know what to do. You will be asking for the buttons and the locations of these inputs. Also, alongside, I've been teaching in universities. I teach MSc students in University of Leuven in Austria. It is still going. And also delivered the SPE lectures, and also at the University of Houston, I deliver some guest lectures. So I've got a special interest in the well planning. Directional well planning is my kind of first very active job with a lot of operators. And I believe if you are a good directional well planner, you can actually save a lot of cost. Okay. Yeah, I think this is the kind of single slide that I usually show to people. Get your mindset right. If you want to embark on getting on learning something really, really valuable, what you need to do is to get your head right and say, okay, I need to have right attitude. So in this triangle, it is showing you the recipe for success for any team. People are number one, of course, and the processes, if you put the processes right, people will follow the process and you will equip them with the right technology. Technology is the third most important part. If you don't have technology, people use old-fashioned Excel sheets. People use other calculations. But if you have wrong attitude, then it'll be a little bit trouble. So I would like you guys to come on board with the right attitude. You may not have all the skills, you may not have all the experience. With the right attitude, you will gain ground, and I promise you that. And I was quite surprised that there are a lot of people who want to learn. When I was a little bit younger, I looked for these opportunities where people can learn practical skills. Courses will be all theoretical. There are not many software-based courses available at that time when I was younger. So in your case, I think you are nicely placed. People have softwares, people can bring in software with the training, but you need to get your attitude right. And it's a sort of tough love that people, just I'm saying this to you that you should have right attitude, because if you are younger, you got so much passion and so much energy. You could actually channel that energy in the right attitude. Then skills will come by themselves. And you will be impressing people when you are being interviewed by some of those companies. They would like this attitude. They can see the attitude and they will invest into yourself. Okay, so this is just a kind of very short slide about the attitude to be right. Okay. Which industries you could work? If you are a good directional well planning engineer, directional well planning engineer traditionally is the first job that a youngster gets when he gets his first job in the drilling. People say, why don't you become a directional well planner? This is sort of out of the college thing. And out of the college, people say, okay, you are now the directional well planner. These are the gentlemen who will train you, or these ladies will train you. They will get you trained up. Directional well planning requires heavy use of software. But in order to be successful and do your planning correctly, as I mentioned, you need to marry it with concepts. And also evaluate your work. You are the best judge of your well trajectories. You can draw the trajectory in 5 minutes. If I just give you the surface location, and I said, you drill from here, this is your surface location, and this is my target. Do this and don't do that, and apply these constraints onto your directional well plan, and make me a trajectory of this shape. You could probably do it in 5 minutes time, but I think for you to be successful, you have to remember that you have to do a lot more than that. And this is why this course is all about, to make you the kind of pro in this kind of domain. So for the industry you can work for, oil and gas, huge amount of work is going at the moment. Everybody is planning. A couple of days ago, I had a chat with a national oil company in the Middle East. They have been drilling 600 wells every year. 600 wells. And about the geothermal wells, in the European Union and in a lot of countries, Kenya, Uganda, and other places, Turkey, America, Canada, they are going a lot of geothermal wells. Geothermal wells are complicated. Their designs are very complicated because of the high temperature. The design needs to be strong. The casing needs to be in certain ways. The shape of the wells are not so complicated. Anybody can draw the trajectory for geothermal, but they are required. Sometimes they need some deviation. Sometimes they need a little bit tricks. Carbon capture well, injection well, water disposal well. Okay. And then more recently, I work on a project where they suddenly lost their water extraction valve. They were extracting water from the downhole mines around 1,000 meters, around 3,000 feet downstairs. They suddenly lost their water extraction valve, and they wanted to design it. Now, usually they are vertical wells because they go straight down and the pump will pump things out of the mines. But this time it was deviated well, 75 degrees, because they have to come from far place. They cannot be just above the mine because of the existing infrastructures and all the site was developing. So they have to come from very far and hit the mine floor. And that mine floor, they will run the casing inside. That casing is a pipe. And then you can extract water out of the mine. So yeah, what I wanted to say, there's a kind of a lot of things you can do with it, with this technology. And more recently in the UK, I think it's in the Cornwall, people are drilling wells to extract salt water, which has got lithium as a trace. So they will process it, separate the lithium out of the water, and that way you can use it for the batteries. So I think this could be the nice little, but 95% of the time you'll be talking about oil and gas when you're talking about directional well planning. Okay. So yeah, this is the picture that is actually showing about the flow of event whenever somebody wants to develop any oil and gas. The first thing that they do is they actually go into the area and start to drill the wells on the left-hand side. Okay. And they after some time, if they are happy with the results, they can actually drill hundreds of wells, like I said to you, about 600 wells in a year. There could be only maybe 6 well, it could be 100 well, or it could be even less. So it depends upon the development. Development is they already know the boundaries of the reservoirs. And they just wanted to, multiply the money, basically. I mean, on the very, very first time, they are risky well because they are looking for oil. And the planning actually reflects it. Planning could be very long reach well. If they are unsuccessful, there is no oil, they will pull back up. They will sidetrack in the open hole and they will go far, far away. Try to find the oil. So the first phase will be finding the oil, looking for the oil. The well shape, it reflects it completely. As a well planning, You will see those wells, sometimes simple vertical, sometimes they are open hole sidetracked. They're turning to the left, turning to the right, trying to look for something. Okay, so they are not the proper well, proper production well. Most of them are just looking for oil, and then they will drill proper well. Proper wells are symmetrical. These dozens of hundreds of directional well in the developmental phase, they are the one which last 30 years, 25 years, they keep producing because they know where the oil is. They are less risky well. They are regular shape. Like if it's a horizontal well, it's going to be horizontal. However, the explore and appraise, they could be any shape. They could be dropping without any plan. If they cannot find the oil, what they're going to do? They are already in the hole. They look elsewhere. They will plug upstairs and go to the left, go to the right, go to the downstairs, do all kind of tricks when they are still finding it. If you find it, then you say, okay, I found this here. Let's calibrate the subsurface model. Then they drill some more wells to verify the boundaries of the reservoirs. And then you move to the green part, which is, okay, let's multiply the monies and drill 5 horizontal here, 3 verticals there. I want multilateral, I want this and that. Then you go about making money. The bonanza of money comes in, number 3. After some time, you say, okay, the production is not getting any better, and I think it's getting worse, so we need to fix something. So sometime, as a part of the workover, people say it is better to maybe make a sidetrack. Maybe this well, all these location is all damaged. Why don't I cut a casing and go to some other location? And that could be your directional well planning side of it. At what point you will cross over and sidetrack and what you will do. So a lot of workovers could be sidetracking the existing well. And also remember this, if you are converting your wells from oil and gas to geothermal, sometimes they also do sidetracking because they want to change the mode of the well. If you have the well that has not been producing, it was previously oil and gas, what you want to do is actually make it useful using the same architecture. Maybe you can go for changing this to geothermal well by deepening it if you happen to deepen it. For geothermal wells, it's a different ball game. They are location specific. You cannot just say, okay, I got these oil and gas well. Can I convert them to geothermal? A lot of time you cannot do it, but sometimes you can. There needs to be certain temperature gradient, certain availability of hot water, because geothermal is all about hot water and steam. It's location specific, but it is something that people have done. They call them repurposing the well. You are repurposing the well. Sometimes you use the directional well planning for it. Okay. If everything else fails, you say, okay, it's time to retire. It's just like ourselves. They also retire. People call them asset retirement. In the retirement phase, they close them off, plug and abandon the well forever. When you say plug and abandon, it means you will get rid of them completely. There is no rejuvenation in there. Yeah, what I wanted to say that you will be doing a lot of directional well planning around the life of the well, especially number 2, which produce the money out, basically, which extract the money out of the ground. Number 2 is the one that you will be 90% of the time you will be involved with these, planning the developmental wells. Developmental wells are like cookie cutter wells. Somebody will come to your desk and say, Mr. X or Miss Y, why don't you give me 10 horizontal wells out of this location? These are the targets. These are the shapes. I would like you to kick off from here. Give me the build-up rate of this. They will be very specific. And same with the exploration phase. They will ask you to do the similar things, but if and but system. They will give you, okay, one well this shape, the other well that shape. Both of them are exploratory wells. One is going in other direction, the other one is going in this direction, looking and chasing and finding oil. The developmental wells are kind of something that people focus more on because they need to be nicely placed in the reservoir. People know the reservoir, and it's your job to place the well optimally, do the geosteering if you have to do geosteering, and that's what makes money. Okay. Um, okay, so let's talk about very basic things. When somebody say, I want to be a directional well planner, must be kind of interesting. So let's talk about the basics, what you should know and what you should learn. Okay. So let me bring up another presentation there. Yeah. So these are the basic shapes. You have a surface location, you drill vertically, and then you kick off. These are just definition. What it is telling you is you drill vertically to certain point. Why you drill vertically? Because the formation upstairs are very soft. If you kick off in the soft formation, the build section will be very weak. The wellbore stability could be not very good. And why it matters? Because you may not be able to run casing. The wellbore might collapse or something. So they have to come up with certain location, kick off in a little bit firm formation, and then build the angle. You will instruct your software, say, okay, I want to build 2 degree every stand. Every 30 meter, I want to build 2 degrees or 3 degrees, whatever build up rate is safe for you. When I say safe, which means that depending upon the area where you are drilling, there are build-up rates which are easy to build, and some build-up rates are not easy to build. For example, in certain soft formation, if you kick off, you should not go more than 1.5 degrees or even less because the formation does not allow for it. So anyway, so these are the section, these are the trajectory shape, and the whole section means it's not turning, it's not building, it's a tangent. Then you have a drop section. Sometime you have a drop section. Usually you have, and this shape is called S shape. It's only going in one direction. If you are turning, building at the same time, this is the 3-dimensional S profile. And the other kind of very popular horizontal wells in America, people are drilling a lot of fracking well, hydraulic fracturing well, where they will go just at certain point, they will just kick off and build horizontal really quickly. When I say really quickly, 12 degrees for every stand. Every 30 meter, they will build 14 degrees. And in just maybe 4 or 5 stands, they become horizontal. It's a huge curve, very sharp curve. People call them short radius. If it's at 12 to 14 degrees, people call them short radius build. And then you have very long horizontal, 10,000 feet of it sometimes, 5,000, 10,000. This is the fracking well profile on the right-hand side. Extremely popular, but again, it's a location specific. What it is doing is to get into certain shale formation that has got oil mixed in it. And when you hydraulically fracture this 10,000 feet exposure, you get a lot of oil out of it because it all cracks up and joins, all the cracks join, and the oil get released because of the pressures around it. It goes to the open hole and they produce out of it. It takes a lot more technical things. It's not so simple as I said. I have been involved with some of those. Fantastic thing to do. Amazing the way that they do it. They are usually finished in 10, 15 days. Sometimes they are so fast at it. They are really great at it, actually. Similar wells elsewhere I drilled, it takes them 6 weeks, 2 months. They do it in 15 days in America. Why and how? They have only one casing. seven-inch line, 7-inch casing. That's it. And then 8.5 inch out of it. And there you go. Everything is done. And they run the 5.5 inch or 5-inch uh, casing in there all the way to the TD. So it's a fantastic thing that you'll probably be involved with some of those challenging ones. And a lot of these, I mean, the simple ones are already gone. Not many people are drilling simple wells because all those have been already been drilled in last 110 years. People have been drilling for 110 years. The easy ones are already gone. Nobody is actually doing the simple well planning. They are doing the complex well planning. Most of them are. So you'll be involved with more fun part, building, dropping, turning, holding, and all these stuff. So these are just the basic shape at the end of the day. Also, you should know about the coordinates. When somebody said to you, okay, I want to drill my well from certain location. When they say certain location, they give you specific coordinates. They will give you latitude and longitude. Latitude is in this picture, very, very nice picture. You can see Nigerian offshore on my right hand side. If I bring in my laser pointer there, you can see there. This center one is the equator. So the latitude is an angle from the center of Earth up or down. If it is up, it's northern direction. If it is other way around, downstairs. So what you do is actually at the location of your interest, for example, offshore Nigeria here, the green star. What will be my latitude? Very small number, like 2 or 3 degrees inclination. I'm talking about this. I'm talking about just that inclination, that from the here to here, not going all the way up because it's right next to the equator. So the angle cannot be so much for the latitude. It's in the direction of north. That's why it has got N on it. Now, for the other thing, which is longitude, longitude is the angle in the horizontal domain, horizontal surface, measured from prime meridian, which is considered 0 degree. The zero starts, it is in the UK actually. I think is a Greenwich area in the UK, in England. So your location, for example, in this picture, which you are looking at, they are calculating the latitude and longitude for New Orleans. New Orleans is right here where my cursor is. What will be the latitude for it? Its latitude is 30 degrees from the horizontal plane, vertically going upwards. When it goes upwards, it's north, 30-degree north. And how it is rotating away from how it is measured from horizontal path, which is longitude, from the meridian in the UK to the New Orleans meridian, which will be this guy. So you're measuring the angle between them and which way it is from there. It is to the west of it. Okay. It is the west direction. If you say north is here, west is here, east is on that side. So it is in the westernal direction. So when you read any coordinates, bring this up, bring this kind of understanding. Why? Because as a directional well planner, you need to get your surface locations right. If the surface location is wrong, everything you have done is completely out of the picture. Digest the location, rationalize the location. Does it make any sense? Go to the Google, type in these coordinates and see where you end up. You will probably see yourself in the right place because you guys are smart. But be aware of all these N, north, west, 30, 90, whatever degrees are, you need to try to match it with where you would like to be. If you make this north as south, you will be exactly opposite direction downstairs in South America or even farther away. You will end up with in some wrong places. West, north, or degrees are different. So these are very simple things. People can get them wrong. I have got them wrong myself. For Nigeria, I have got a little green dot there because we will do some exercise on it in the software environment. Okay. It is telling me that my latitude is not much, only 2-3 degrees. And my meridian will be, okay, it will be on the side. It will be showing the east of like 5 or 6 degrees because 0 to 10, it's right in the middle, like 5. I should be seeing 5 for the longitude. And for the latitude, I should be saying 2-3 or something like that. Okay. If I am drilling in offshore Nigeria. Okay. So that's my expectations using this small kind of chart. Also zones, when somebody define the coordinates, global coordinate, they will give you the latitude, longitude. They also give you the zone. The zone is a grid. It is the UTM stands for Universal Transverse Mercator, a coordinate system that assign location. So we have the grid imposed. It is like a big chart. You wrap it around the globe. You wrap it around the globe, and you open it, it looks like this. Just like you have sliced the earth into 2 equal halves and open them up and put this grid on the top of it. Every kind of country, they have zones. For Nigeria, it is, I think it's 29. You can see the star, the green star again. 29 and 30 is the Nigeria. And on the left side of it is got some oceans. Okay. So these are the things that you will slowly learn. What I would like you to do, though, is to start gripping your mind on location. Don't move on without you understanding what you have been given, and then you implement it in the software and double check it. If the software is taking you to the right location, in this software, the Innova software, they have got Google Earth built into it. So if you do anything mistake, you will see it, which is great, basically. But just to kind of be aware of these small things, because you'll be using some other software. You may be using some other leading software. They don't have Google. You cannot see where you are really. You just have to trust your, let's say, expertise. But this Innova software gives you a chance to survive these mistakes by showing you where you are physically, looking at the topographic map. Okay. Now, talk about survey correction. Whenever you take a survey using the MWD LWD tool, it uses the magnetic north reference. The survey you get out of LWD, MWD requires certain corrections, and those corrections are applied to all the surveys. Magnetic declination, because the Earth is, have the magnetic inclination, magnetic declinations. It has got the kind of magnetic field that actually can be calculated using the software. The software will calculate this for you. However, you should be able to do it manually as well. If I give you the values for magnetic declination, grid north corrections, and then you can apply. These are the things that you can probably learn in a proper course, but be aware of these corrections. If you do not correct the surveys properly, each and every survey you take will be incorrect. It's a systematic error you imposed on the location of your well. Your well will be in complete different place if you do these wrongs. Critical to respect the survey correction. MWD tool, you cannot use survey directly. azimuthally, especially for azimuth. Inclination, yes, you can. But azimuth, you cannot just use whatever the LWD is telling you, because you need to apply certain correction depending upon where you are. These numbers are not fixed. In different areas, there are different corrections. If we were to do the course, Innova has got the software that calculates the correction, and you can visualize, you can hand calculate, because this what separates you from brand new people. If you know if the corrections are right or wrong, because the impact is very bad on, if you get it wrong, your actual well will be very far from where it is. It is for drilling, basically, the surveys, but you also use it for planning. Okay. Every time you take a survey, your azimuthal direction, your azimuth could be slightly off from reality, because all the measurements have errors. Surveys are not 100% correct. For example, if I were to explain it, there will be an ellipse of uncertainty around your survey you just took. Your survey point is right in the middle, but actual survey could be on the right side, on the edge of this, or on the edge of the other side of this. It's called semi-major. It's like a rugby ball. There are rugby balls all the way from top to bottom. Some of them are circular. If the well is completely vertical, this rugby ball will become a normal ball. It will be like a circle, because if you are drilling horizontal well, this rugby ball has very flat, just like this one is. This one come from. So it depends upon the shape of the well, uncertainty, and also the tools you are using. If you are using very refined MWD, LWD tools, then this rugby ball will be short, small. Up and down is a TVD uncertainty. TVD is also uncertain. If you try to land the well in the thin bed reservoir, you may not be able to hit the reservoir because of the TVD uncertainty. There are ways to correct them. Sag correction, for example. You have all kind of correction you can apply for the sideways uncertainty of your survey points, or up and down, which is TVD uncertainty. There are ways to tackle it. Be aware of these things, because if you don't know, then you don't know what to do. But if you know something, you will find the answer, that how can I reduce the uncertainty so I can place the well where I want to place for best production, for example. On the right-hand side, just a jargon. People use the jargon about offset well, my reference well, my offset well. Okay. Reference well is the one you are drilling. When somebody say offset well is very close, you should know what it means. It means that you are drilling, and the well which is in the vicinity is one of the offset well. You are called a reference well. The well you are drilling is okay. Whenever you run the anti-collision against the offset wells, offset well 1, offset well 2, it gives you a distance and safety factors and stuff calculated by the software against offset well 1, offset well 2. It will give you two numbers. Say I am this much far from offset well 1. I am this much far from offset well 2. At every station, you are drilling at 10,000 feet. At 10,000 feet, you are this much away from that one. You are this much away from that one. When I say this much away, now we have to think about center to center distance. What is the center of this against center of that? In the horizontal plane? In what plane? Important thing is the system calculates it in the 3D plane. For example, the closest distance is not here. It could be here, like this. It could be in that direction or in that direction. Three-dimensional closest distance. That's what system calculates. When it says center to center, It depends what you are looking at. Not in the horizontal well, not in the horizontal shape. It could be in 3 dimension. What is the closest point from center to center? Another thing is called safety factor. You will hear safety factor a lot of time if you are a drilling engineer or drilling person. How they arrive at it. What does it mean? The safety factor is very bad. Safety factor is bad when ellipses of uncertainties are touching or coming close to each other. So separation factor is calculated depending upon the distance between edge to edge, uncertainty to uncertainty. Are the uncertainties are touching? It means that there's a possibility of collision. Level 1, level 2, level 3. Level 1 means there is no distance left between the two ellipses. Like the one you are drilling has this uncertainty of being here. Your well could be here and your offset well could also be here. If they are touching, it means that they can be hitting each other. It's a bad news for drilling. When you see safety factor comes to 1, people stop drilling because it's too risky. They may be hitting other wells. 1.25, you stop drilling and try to turn away using, just to go away from each other somehow directionally. Read through this. I will send the slide pack anyway to you so that you can probably use it and absorb the information. These information pieces are available online as well. So you can actually appreciate the safety factor. Safety factor is very, very popular and very common when people talk about any wells they are currently drilling or they will be drilling. Safety factor should not go more than 1.25. If it is getting close to 1, stop drilling. That is usually written in the policy of a company. If it gets to 1, you cannot drill anymore because you are very likely to have high risk of collision because the uncertainties are touching. The well could be here, well could be here. They are colliding. Okay. So be aware of it. And I think that will be a separate topic. In every big company, they have certain people. They look after this. They are directional drillers. They are survey management people. But as a planner, you should know what it means to be one. What will you plan it for? You will want to plan it for level like the ratio should be 2 because it can easily become 3, 2, 1. When you're drilling the well, it changes. So you may not aim for anything more than level 4 level, like the ratio should be 2 for your planning part so that you are safe as you could be. Okay. For drilling part, things change, things happen. It could come close to one of those levels, but you don't want to plan for those levels. Yeah. Okay, so also you should know about the rigs because why you need to know the rigs because you need to put in the reference of your survey when you are doing the planning. Somebody said, okay, I will be using jackup. Jackup rig is the same as this one, for example. What would be my survey reference point? Where are we measuring survey from? To answer that question, you should know the rig. On the land is different. On the land, you have ground level. Ground level is elevated from mean sea level by whatever, hundreds of feet. And then you have elevation of the rig. Okay. So these are very tricky. If you mess up that one, don't understand that reference point to be right, all your surveys will be off. You will not find the reservoirs at the depth because you did not reference it correctly. You're measuring the inclination and the survey points at the wrong spaces. This is the one that actually can destroy a very nice system. I have been on some of those wells. People went to the reservoir. They wanted to land horizontally. They could not find the reservoir. They got totally crazy, basically, because they've been drilling in the area for last 5 years. They are not new wells. They always find reservoir at certain TVD depth. Then they, I mean, after the investigation, of course, they understood that somebody put in the wrong elevation. And all they have to do is to drop by 10 feet to hit the top of the reservoir. Those are a real life example. I would like you guys to know, to appreciate how to put in measuring points correctly, elevations correctly. Very, very critical for a well-designed engineer or the trajectory design engineer. Here is the answer for it, okay? In all the softwares, regardless of which software you want to go for, platform, jackup, they are actually like a frame sitting on the ocean. You find out what is the water depth. You find out what is the air gap, which is the distance between the blue part and the rotary table or the kind of air cushion. Okay, it's a small number usually. Water depth could be any number. It could be 60 meter, 100 meter. And then you apply that information about the rig. If you don't have the rig, if you are just planning a well, you don't have any information, nothing to worry. You can actually leave the air gap to whatever, 0, and make sure you have MSL, you have some reference point. You don't need to have air gaps. You can actually design the well from the mud line. You can have it, you can design the well from the mud line. You can design the well from mean sea level if you don't have the rig, because the rig actually changes the air gap. If you have a big rig, big air gap. A small rig, maybe you have a smaller air gap. You don't know that. So you can actually design the offshore well from the mud line because the water depth usually stays the same. And then add it on the top of it. When the rig arrives, you know the rig now, you can start to increase the top end of your profile and trajectory. Very simple. People do it all the time, by the way. Subsea well, floating wells that has got no connection between the floating part and the mud line. The mud line is sitting far away. The BOPs and everything else on the mud line, totally different ball game. They are deep water, okay? They are very, very expensive. Everything is expensive. The daily running cost of a jackup rig is around $500,000 per day with all the services they are drilling with. The subsea well, it could be 1.5 million, 1.2 million for every day. If somebody messes up and do the mistakes and they have to do some repairs or fixing, huge amount of monies. That's why people get run off from the jobs if they do mistakes. They are very expensive thing for the vendors. They get rid of people right there at that point. If somebody is not doing their job right or something keep failing, it's very expensive, the first two. On the land rig, onshore is very popular. It's a little bit crooked as well. You can see you need to remember the ground elevation. Instead of having water depth, you have ground elevation. You need to add that ground elevation on the top of these, and calibushing, which is where you are drilling from. You know, it will be the rig floor, it could be the drill floor. Okay. So you need to add that into the empty slots. And remember the picture. All these pictures, they should be filled in the way you see it. It should make sense to you. When you have applied it, you should be able to see this just like that. Don't just run away from this one, because this is the one that should make sense. If something goes wrong, people take a picture of what you have done here. By taking this picture, they know if you have done it right. So you should take your time. The air gap should be a small number, and water depth should go here, which is the mudline depth. What it is saying is mudline depth is this, and then you have an air gap sitting on the top, and you're measuring from it. You're measuring from the summation of it, which is 335 in this case. Okay. Let's just show you around a little bit more. If you happen to be drilling in the area, you can choose your surface location, A, B, C, D, E, and also you can make it as a like a sidetrack. As a planning engineer, people will come to you and say, okay, I want to get to this rectangular reservoir. What is the best location for me to drill? And now ball is in your court. So what I wanted to say is there are several ways you can do. You can ask them what azimuth they would like to use, what azimuth they would be entering the reservoir with, what are their kickoff points where you can start to build. Are they okay with the turn? You need to ask all these questions because you just cannot just get on with it and give them some answer that that will be proved wrong later. So you need detailed instruction from them which locations are no-go. For example, on onshore land rigs, some locations they have schools, sometimes they have trees, some areas they have protected water reservoirs and the lakes. How could you know just by that? So you need to ask them which locations are not allowed, which locations are allowed, which area or zone you are allowed to find your location, and can you come from these existing well? Instead of drilling the full well, can you just sidetrack from an old well and hit the reservoir? Would that be acceptable? You could ask this question. That way you can do all kind of options. And also you can calculate the number of like a footage. Which one is the longer well? Which one is the shortest possible well? If you select this location, and then you can also calculate indicative cost because in every area, every meter people drill, they have a rough estimated cost of drilling, especially for developmental well, where they have been drilling for a long time. Okay, for every section, they have these footage cost. You can multiply that and say, if you go from, let's say this A is a little bit too far, this could be suitable for whatever reasons, but I see D is better or C is better because the footage will be this much shorter. And I believe this will save you this much money. You will talk about money straight away because you know the kind of footage cost from your experience of drilling in the area. If you don't know, you can ask the drilling engineer. He could tell you that as well, just to compare options. And so you don't just pick up whatever makes sense. How about A? Is A is any good? This is the real example actually from real well that I have designed myself. They wanted to go with A. You know the reason why? A is turning and building and moving and longer. They wanted to go with A. Even after I told them they can go B, C, D, they told me this area is occupied by some people. They want some money or otherwise they will be very upset or whatever. So they have to go out of their zone and drill from outside of their area just to protect themselves from uh, all the harassments and things. That was in deep parts in some other countries. So I think it's a fair thing to say people have their own ways of doing things. But anyway, so these are the thing. And what I highlighted here is very big thing that you can draw any trajectory you want. You need to run it through the well engineering models. This is exactly what we should do. When you draw any trajectory, take the trajectory, plug that into well engineering models so that you can see if they are easy to drill. Is the torque is deliverable? Can you handle the standpipe pressures? Are the ECDs are going to be okay? The BHA they are planning, can we use the BHA with this plan? Very, very important to put two halves together. One half is what they have been doing, writing in the drilling program. would that fit with your trajectory? The mud weights and the BHAs and the drill pipe, would that match up or no? That's the important part right there. Okay. To also give you some examples of optimization, there was one incident where somebody gave us a target. Uh, we say, and they gave us a location as well. People say, okay, guys, this location is my favorite, or this location I think we can drill from. When it came to me, I say, okay, let's design a well for you from this location that you are asking and go to the target in certain, and they would like it to hit at certain inclination. They would like to hit the target at 55-degree inclination, as you can see in the box. In the box, it's a 55-degree, 45 degrees. 55-degree inclination at the target and 45-degree azimuth at the target. It was required by them. And this location A, I told them, can we bring the location close to the target so that we can reduce the footage so we don't have to drill so much, still keeping the constraint. Inclination will be still 55 and 45 for the azimuth. They say, yes, yes, go ahead. We are just planning. We improve it in 2 steps. Location C was my favorite. I told them if you would like to hit the target at 55-degree inclination, you have to actually come from this location, location C. And don't kick off until too late. You can kick off very deeply. That way, you don't have to use expensive directional tools. You just kick off and hit the target. That will be shortest trajectory. When we multiply the number for deep water well, it was $5 million saving for that well. $5 million just by tidying up the things, asking question. Whatever they were asking was quite expensive. You would be surprised that a lot of drilling engineers, they are project managers. They will go and talk to the directional company. They say, directional guys, why don't you give me a trajectory from location A to the target? That's it. End of conversation. However, if you are a proper engineer, you will ask question and try to arrive at this kind of very simple optimization. They are simple if you ask for it. They are almost non-existent. No optimization if you don't ask for it. Okay. $5 million is a big number. And they were surprised with it because they say they have never had anyone who asked these questions and improved these like this. But I think it's a fair thing because it has become a kind of style of work which we can change. The people like ourselves who are kind of deeply grounded in technical expertise. I would also like to bring up ERD wells, extended reach, going far away, different long horizontals and long step outs. ERD wells have become very popular right now. In a lot of places, they love these kind of wells. They require special planning. Whatever you plan, well engineering should verify it. As I mentioned, is a more need to verify them because they are very complex. Some well you cannot drill them. What they do if this is the case, they shorten the length. They shorten the difficult part, the horizontal lengths or the ERD part to match with what the rig can do because the rigs are not very big a lot of times. And sometimes you have to compromises. So you go back and fix your ERD wells. ERD wells are the most complex well. The limiting factor will be the rig and the drill pipes. You want to go for big rigs. You want to go for the biggest, strongest drill pipes. But you can still be limited in certain ways, which you will find out when you run your trajectory with the well engineering software. Okay. Now, these are also shapes of various well. Looking from the side, which is just a section view, is telling you the versions of ERD extended part reach going far, far away from the origin. Different shape. Some are just building up, holding all the way. Some are building and holding and then building again. There are different variations in there, which you will probably see sometime, but most of them are similar to the first one with the one that kicks off and go all the way to the TD. Some of them drop at the end. Some of them drop into the target. Okay. And now we talk about how to go about it. If you are very experienced, you want to see the offset wells, check on the offset well to see what had been a problem with these delivering the dog legs. Can we use motor? Can we use RSS type tool? What had been the problems that previous well planning people have seen? Anti-collision problem was the issue. If there was an anti-collision problem, you may want to improve the separation between the well in the planning phase. If you have problem building the angle, you may want to go for field development planning. You want to see how the field was developed. When I say field development planning, you're talking about a bunch of wells being planned, a lot of targets. I will give you an example actually. Okay. Also, you do the well engineering, detail analysis, and also this kind of thing that you plan during the planning phase, you do a lot of things. The last two or three things, the last two things are for drilling part. When you are delivering them, what you will be watching over and carefully looking after. You will be making your drilling positions as close as possible to the plan. The plan and actual should be right on the top of each other if you are doing the proper directional drilling and not deviating from the plan. Course correction means if you get off the plan, go back and merge to the plan. This conversation, merging to the plan, people talk about it all the time on the rig when they're drilling the well, because for whatever reason, they fall off the plan and the directional driller want to merge back to the plan. If he does not do it, all the anti-collision that you have been doing in the planning phase will be incorrect, basically, because your actual plan is not the same. Okay. I'll go quickly because I think I'm a little bit tight with the time. A lot of time they have huge cost escalation. Cost is going higher. People are upset about that the cost of the wells are too high. The reasons are some of them are under your control, some of them are not. For example, supply chain, and there's also the lack of experienced people. So you can read through them at your own time. I will send this slide pack so that we can focus on something else at the moment. Before you can plan any well, what do you need? What do you exactly need before you say you are ready to plan it? Okay, get yourself exact information with the mapping grid, which is the coordinates, latitude, longitude, and also called CRS system, which is actually the coordinate reference system, CRS system. What are the north references? What are the survey corrections? What are the surface location? If they already have got surface location, and what target those are. They will give you the target. They will give you surface locations. They will also explain what mapping grid and coordinate system north references are going to be used. If they don't say any one of them, you cannot plan. If you don't have a target, you cannot hit the target. If you don't have a surface location, ask them, can I select a surface location? Would you allow me to choose a suitable location? You can do that. You can start from somewhere and then shorten the trajectory following the constraint, of course. Constraints are the biggie. You need to ask for constraint. Where to kick off? What is the allowable depths of the kickoff? Also, you want to know offset well. Why? Because you plan your well, and next thing somebody say, hey, there is a offset well. You already hit the offset well in the planning phase. So sorry, I did not give you this offset well. You need to have offset wells so you can avoid them. You want to not to hit them. So you need offset well before you can even do planning, because you don't want to hit any one of them. Okay. What is allowed? What is not allowed? Some targets are allowed to be changed. Targets are not made by some massive, super smart computer. They are geologists. Okay, they are like people like who say, okay, target, you can move it 100 meters to the left. You can sink the target for, let's say, 20 meters down. Why do you want to know? Because sometimes the targets are too difficult to hit and making your trajectory very complex. Can you move this target 100 meters to the right or to the front? Maybe your trajectory will become easy to drill. So you need to know the flexibility. Okay. Casing program, all this stuff, you can decorate it. You need them actually to see what section you are drilling and stuff like that. But the top 4 or 5 are really important. Top 5, 6, if you don't have them, don't bother starting it. Okay. A little bit more detailed explanation of it. Okay. Lesson learned from past. Okay. You want to improve your plan. So you want to get anti-collision information, anything that had been bothering them. Kickoff was okay or not okay. If the kickoff is not okay in the past, kick off deeper. So you know the kickoff depths were not good. So you suggest them, okay, I will kick off 500 feet deeper or whatever, Technology, what technology are they going to be using? If they are going to be using mud motor can do all the profiles, very, very popular. RSS tool, most of them cannot do certain dog legs. Certain dog legs, you don't want to plan it. If they are going to be using RSS tool, don't put certain dog legs that is very difficult for RSS. For example, if you really want to know, in the top hole section, when the formation is soft, kickoff is very difficult with RSS. Okay, so don't put kickoff at that depth if you are going to be using RSS tool. So you need to know all this stuff about these things, okay? So that you can plan accordingly. You need to be hands in hand with well-designed engineer or drilling engineer who is writing the program and have the BHA information. How would you select which technology for what formation, what section? So this is a small sheet I put together. That was actually from a real well. You can put what you like to achieve with this BHA or this technology. Write down your option vertically like this and pick the one that delivers everything in green. Everything is achieved. So it's a kind of something that you can probably absorb later. Okay. So this is the field development planning. When just assume yourself that you are arriving at a location, you have been drilling in the area for finding the oil. You found the oil, you have found the oil. Now it's time to drill a lot of wells so that you can hit all the targets for certain reservoir and produce from them. You are building wells so that you can produce 8 of them. So you arrive there at the location, create a pad on land, for example, and then you create these slots. These slots are the start of wells. The rig will drill OWE1, finish the well, hit the target, move on to OW2. In the same fashion, it keeps crawling and moving, drill all 8 wells. From the same pad, the rig will move maybe 10 feet away from each other, 6 feet away from each other. On the offshore rigs, it's usually 2 meters, 2.5 meters. On the onshore, you may have more space available between the slots. Slots are the spudding point that you plan for your wells. This is how you build the field. If you have a lot of well, more than 8, for example, you will have several pads. Each pad will have 8 or 10, or even more or less. There are something called super pad on it. In Kenya and other places, we have few hundred wells that we were planning on. They have few super pads, something like 36 slots in each. All of them are separated like that. Then you plan from each slots. From each slot, you will be planning. Looking from the top, it will look like this. Okay. You have 8 wells. Looking from the top, you see that it's going away from each other, not intersecting each other. You need to plan them in the way that you pick up the targets which are in alignment so that they don't cross over or try to hit each other. In the ideal world, people call them a spider plot. Looks like a spider's leg pointing out. These targets on my right-hand side, it's a top view. It is showing the top view of a field target. It's got a lot of targets, and you need to put the slot, your pad structure somewhere so that you can hit the target in the shortest possible way. Optimization of the footage. If I place my pad here, for example, all these wells will be longer. If I place my pad here, most of my well will become shorter because my targets are close to my origin. It's a trial and error. To optimize it, you will say, can I move some target closer? Is that okay? Can I move? Okay, are these kind of spaces allowed for the pad location? Can I have my pad moved here in the planning phase, of course? So you can actually ask this question, which areas you can do, which targets you can move. The goal is to bring them tightly together and bring your pad in the way that all the well becomes shorter when it comes to drilling. Okay. And then you summarize this kind of thing. You say, okay, out of my wells, I got few option of my 8 wells that I am planning, option A, B, C, for example. If 4 of them become horizontal, I can make them horizontal, and some of them are vertical or slightly slant. What is my total footage? What is the total length of my 8 wells? A, B, C, D, and what will be the benefit of this in terms of production? What production am I going to get out of option 1, 2, 3, 4, X, B, L, J? So you can actually rank and choose what combination of well out of that well pad, which one will give me how much money for the production, what is the cost of delivering them, and rank them accordingly. Based on that, you can also calculate how much casing you need for 8 option. Now for option B, for example, you have 8 wells, 3 horizontal, 5 are non-deviated, but they are not horizontal. What will be the length of each multiplied by number of type of wells? Because we already know what's the length going to be at each point. So we can also calculate the cost of steel, the hardware, basically. Okay, so you can actually calculate it. Now, we got a little bit of time, so let's just quickly show you around a little bit about the software. Before we go there, I would like you to kind of feel for what we are trying to do here. In this session, I will pick up a location offshore Nigeria. Okay, offshore Nigeria, say field, whatever the field name is. I will create 8 well slot on the platform. I will create a location, which is a platform, create 8 trajectories out of it, and I will let them go to the targets. And then I will run the well engineering on my trajectory to share to check if the trajectories are okay. If the trajectories are not any issues with the risk, or they are okay to drill with. So this is the kind of rough idea. If you were working with me, I will give you this as a project, and you will do everything by yourself. And you will find me the location. I will give you the rough location. You will find me the right location. You will tell me this location is better because my trajectories are shorter with it. If the targets are fixed, targets are usually flexible, but not too much. Targets are calculated by a lot of analyses. So you can choose the location that will make your trajectory shorter. Then you run the engineering analysis to ensure that your trajectories are okay. It could be a small project for someone. It could be done in 2 days. But I'll show you a kind of just a hint of it. And we can also check the requirements, that all the requirements are available to you. Okay. So we can probably go through it just now. This is just information about this platform. This platform has got a 500 feet water depth, and the elevation of this RTE is 100. For example, if I go back in there and maybe share with you the software now, okay? What I want you to do is let's see, quite a few things open. Sorry about that. Just 2 seconds. Well seeker. So this is the software from Innova. It's a very powerful software. Recently, they upgraded it. It has become extremely powerful now, because I have been using it for some time now, training and everything. Okay, let me try to find the one that was there before. Yeah, there you go. Look at this one there. This is just to show you. Okay, this is already done work. This is showing a well that's being drilled. And if I want to show all the softwares, all the other wells in the vicinity, this is the US American fracking wells. You can recognize fracking well because they are aligning in one direction. They are aligning in only just like a tooth comb, just like a comb. Why they are aligning in certain azimuth? Because when they fracture it, the fracture should go up and down only, because they are aligned with the horizontal stresses. Sorry, H min, horizontal stress that is minimum. That way, when you break it, when you do the hydraulic fracturing, the fracture goes up and down vertically, breaking through the walls and the layers of shelly wells. So they are like this. And I mean, I have used these one and they are very fantastic. The blue ones are the plans. The red ones are already drilled. Okay. Why they are swinging to the right and left? Because they are coming from the pad. You can see the pad. You can actually see the pad right there. You can calculate the number of slots, which I told you that they are aligned like this. They're tightly like a spaghetti plate and going away from each other without breaking the anti-collision. The hardest part will be top hole, where they are too close to each other, somewhat overlapping. They are not overlapping in really. The size of the line is showing the big thing. So these things you can build very complex, and people build it, people deliver it. The red ones are already drilled. Blue ones, they are planning to go in other direction, similar azimuth, opposite direction. So let's come back to our option. Suppose I wanted to create a pad on the offshore location. And let's see, this is my one of the well, basically. And I wanted to also show the offset. You can see this is the one that I did for some class. There was a class I taught. I give them all the targets. If I enable the targets and give them the name, okay, you can see, sorry, offsets. Okay, let me bring in include offsets annotation. Okay, let's see. So you can see this is what you will end up with. If you have a pad, and when I want to see the pad, how that actually looks like. If I go to the rig and go to properties, look at the template, this is how it is like. And each template have their coordinates. You can see the coordinates. Okay. What it is saying is my starting slot is 0, 0. And my slot number 2, if I want to see the name, this is number 2. My number 2 is 6 feet up, no side movement. Just go up 6 feet. And then 12 feet, then 18 feet, then go to the right, 18 feet up, and 6 feet to the right. So you can actually see it here, number 5. Okay, piece of cake. You can actually create your own. You say, okay, I don't like this one. Maybe I can have something else. You can have maybe a kind of new. Okay, so just call it BH, for example, and create new. Okay, this one you can actually create any other shape you like to shape, you know. I mean, ideally you want to say I want to have maybe a rectangular pattern, maybe a square pattern, 3 and 3. I would like them to be 10 feet apart from each other. Look at this one. It's like a square. You can have even more. You can have maybe a, a more slot. Let's say just 5. You can have even more. A super pad. Okay. And when it comes to planning it, you can plan well for everything. You can say, okay, so exit out of it so that nothing gets changed. This is the actual exercise that people have done in one of my class, and people love it because there's something that will cover everything, all kind of wells. You can see the build drop, you can see the tangent, you can see the horizontals. Okay, so if I bring you back to where we were, if you are looking at the plan and you can show offset. Okay, you can see it here actually. Okay, I'm enabling everything. So these are showing the horizontal well looking from the top. Okay. So I'm going to change this one just now so that we can focus on something else. For yourself, I have created for Nigeria, I have created this out of the slides which I showed you. So these are the wells. Let me bring it up and 3D. Okay, so it has got two wells because I just plan on 2 wells, gave them 2 targets, very complex. The other one is very long and ERD, the other one is shorter. And if I was to show you, okay, so that one, okay, sorry. So that one, you can actually see it from the top. You can see the top view and you can actually zoom in. You can zoom in and see the slot itself. Okay. Show offset. Okay, so it is kind of something that you can play with. It is very easy to do actually. If I open this and say that you have to do it by yourself, so you can just delete everything just now, and you can actually select it. For example, that one you can start to build it. Let me close everything basically because this is say don't save it. Yeah, what I wanted to actually show you is what I have, how I have built it. But I would like you guys to see it. Okay, I made it to the kickoff point. This is the kickoff point. Okay, let's just do one just now. If I remove it and just say, open up a 3D viewer. Sorry, this is NS5. So let's just do that. It has got nothing in there just now. So you can actually drag and drop to the side. Make this slightly bigger, maybe, so that you can see things. Now, if I say, take me to 2000, keep everything straight, you can see this is start to come up. It starts to build it. I don't see any targets. Let's see the targets. Do we have a target here for N5? Let's see how we can bring in the targets first. N5. Okay, click on the target. So that target is already there. This is N5 target. I have created a target. This is the target coordinates. This is the TBD. You can calculate it as well. So now what you need is to actually hit the target. Suppose this target is at 45 degrees azimuth, which I know of, which I can explain to you. Suppose you want to hit it at 90 degree. You would like to have a 90-degree well. So you select the target and give it a dog leg that you would like to keep. If you say dog leg is 3 is good enough, usually 3 is a magic number for people. 90 degree is my inclination that I want to hit at. 45 is my azimuthal direction to the target. Calculate. When I hit the calculate, it hits the target. Why I cannot see the target? Because it's not enabled. I need to enable the target. And there you go. And you can see the target now showed up. So this is the target, okay? Right there, you can see it. Somebody said, okay, I would like it to be at 65 degrees. And my azimuth when I hit it should not be 45. It could be, let's say, 20. And make my this to be, I would like it to be 65. Okay, so it is now 65, not 90 anymore. Or I would like to maybe swing outside first. Maybe I will have another line. Insert. I would like to turn to, okay, let's say 35 first. Sorry, 20 degrees and 35. You can actually play with it as long as you want, depending upon what they want. Why we are doing this interactive session? Because they have certain requirements. They say to me, okay, this is my kickoff, keep it straight. Give me 2 degrees in the top hole because the formation is soft. Give me 1 degree in the top hole. I will give them 1 degree. They would like to hit the target at certain inclination and certain azimuth. I'm following what they're asking me to follow. They say, okay, this 3 had been a problem in the past. Why don't you give me 2? Okay. It's not going to solve it. Okay. So let's say 3 or 2.5 or maybe 3. 3 will solve it. So you can actually do all kind of work. And this is just one of the things. In reality, you can do a lot of things with this because I am just using one method. You have dogleg method. You can actually do different kind of tricks with it. S-shape well, build and turn. We can go through them for the whole day, basically, to cover everything. To cover everything, you need proper time, kind of examples. So those things you actually need to do. And once you have done it, you are happy with it. You will just say, okay, I will run this trajectory and check on, say, don't save it because I messed it up a little bit. Okay, so you say, okay, I got this trajectory. I want you to copy this trajectory and paste it into my engineering like this. Copy this, Control C. Okay. By the way, you can also add horizontal part in it. Okay, so you copy this one there, and then I will take you back to maybe share something else. That will be my engineering, Innova engineering. So you go to the other software, paste your surveys here in the software. In the software, you already have the plan BHA. In the software, you already have put in the plan BHA. You already have put in the whole section, geometry. Your casing is this, your open hole is this, your mud is this. You put in all that stuff. You updated it with the new surveys because this is your trajectory. Suppose I already copied it in there. It was 90 degree and this. Suppose this is the trajectory that you wanted to check. Can you drill with it? So now you put in the plan engineering parameters. Plan engineering parameters. You update it with this information. Get with the drilling engineer. Ask them, what RPM are you going to be using? What is the plan ROP? What is the plan weight on bait? If you don't know it, no problem. You can pick up a drilling program from similar wells, from similar previous well. What flow rate the BHA will be good for? What will be the tripping speed? They are not rocket science. Everybody have some numbers. They are similar wells people have been drilling. If you don't know, get the similar wells elsewhere. Okay. Now paste in your survey. Suppose I did. Okay. Suppose I delete this all, then put the new one in, right click, paste it. And now I will calculate hydraulics. I will calculate torque and drag. I will calculate snapshots. And then I will have a look at how much flow rate is required to clean the hole. It says this, this is upstairs. You can see on my right hand side between 295 to 300. Let's say 300. 300 GPM is required to clean the hole. The highest you have seen on the right hand side, the dotted line. Okay. Suppose this could be possibly required, or 290, depending upon ROP. How fast you are drilling. Sometimes they want to drill fast. Assume that they want to drill fast as a worst case scenario. 300 GPM is requirement. You must have 300 to go fast drilling. Okay, that's fine. So it could be the starting point. So you can now check on the standpipe pressure. If you are drilling with 300 GPM on my right hand side, you can actually include this 300 in there. Or sorry, maybe you can have this as a 300, 400, okay, 500, 600, and delete this. Suppose you want to start with, let's say 300. You have to do it again, probably calculate it again. Okay. So now you can check on it to see how the standpipe pressure would be like for 300. You can see it's not good because it's crossing the limit. This blue line is a limit. So maybe it's not good because when you come to this drilling depth, the 300 GPM will cross the limit of 3000 PSI. Suppose this is the small rig, just for the sake of assumption. The rig has limits for standpipe pressure. You are breaking the limit. What can you do to break because your standpipe is too high and you require 300 GPM because you found out by running the analysis. Nothing wrong with your trajectory, but something wrong with the BHA. Okay, so you may say, okay, maybe we need to reduce the standpipe pressure. Let's open up this pipe. It's 4-inch drill pipe. Maybe I can use 5-inch drill pipe. Okay, this is one of the problem that you need to fix. Standpipe pressure is too much. We need to open it up. We need to open the geometry of the string. Maybe use bigger drill pipe. Okay, don't just jump into conclusion just now. We know for hydraulics, we do require this. ECD was okay, not okay. We will check it. Suppose you want to check on the torque and drag and see how the hook loads are. Hook loads are showing okay. It's not breaching it. It's only breaching it here. You see that one. It's marginally breaching it at the high friction factor. No big deal. So we can say we need a new drill pipe or maybe some other drill pipe which will give me less ID. ID is causing the obstruction, causing the standpipe to be too high. So you can actually optimize it by playing with it and running through these analyses. I just did a very small thing. In reality, it's very comprehensive. What I am just telling you, your trajectory is okay. You just need to improve your BHA to clear the obstruction so that, for example, if you use 5-inch, just for the sake of it, 4.276 is the one. And let's say 3.5, sorry, 3.2. Just make it, just to kind of show the point. Calculate hydraulics. Suppose you change it to 5, for example. And now what will be the pump pressure? It goes here and now you are okay. Look at the, and this is not the solution. This is just an iteration. What you normally do, pick up another grade of 4-inch drill pipe. Don't pick up the 4-inch grade that you have because it's too tight. Maybe have 4-inch slightly open. So you don't have this drastic, but it's past it. You fixed it by playing with the drill pipe. So that problem is not because of the trajectory. Trajectory was doing okay. And this is what I wanted to show you, but this is only a touch of it. If you work with me, you will see we go from left to right. All these charts, all these things, and also everything else to evaluate if the trajectory is drillable, if the plan BHA is good. If not good, you will tell them why, and you will tell them how to fix it. Okay. Okay, I will stop it here because I think we started a little bit late, but not a problem at all. And I will bring in our slide pack, and maybe I can show you something else as well. This is the course that Dexter Pro and myself are offering. It could be virtual, it could be face to face. For that course, we have put together softwares to bring in the software because it's not fun enough just to do the theory. We will give you well planning softwares. We will give you the web-based softwares and also the software that you just looked at, the well engineering calculation to evaluate the trajectories. And the benefit of this is know how to do it. That's the one big thing about this learning, software-based learning, because these software are almost the same as any other softwares. They are not very super smart. They have the same kind of ways of putting in things and getting the numbers out of them. The good thing about Innova, they are kind of top-notch for well planning. You can see things that are even not available with the big vendors. So you get to have those software for a couple of months. You cannot miss the boat. You will know everything about how to do it. And usually to enter into the drilling engineering expertise, this knowledge is quite essential to be able to build the trajectory because the trajectory holds all the cost and the risk. If you change the trajectory, the cost goes up and down and the risk goes up and down as well. So once you do it in the software environment, evaluate the trajectory, you would be very nicely positioned to be able to deliver the success for your team. It's got a lot of length and breadth of the topics. You will do the field development well planning, the whole bunch of planning for the whole pads, designing the pads, uh, improving everything basically that way, and also learning alongside the well engineering expertise as well. You will also learn well engineering. Well planning is just one part because you are doing both of them. Okay. And that's why we want to give you everything rather than just how to draw the picture. So it will be more interesting for you to be an engineer that also evaluate everything. I will stop it here. We will probably open up the questions. Is that okay, guys, on your side? Extra probe, guys, can you please chip
Yeah,
in
it's
and
fine.
yeah?
Okay. Yeah, go ahead, Reglan.
Okay, so thank you so much, Naeem. This is a wonderful session. It is really, really, really packed. I won't lie you. Myself, I'm not a well engineered person, but the way you have distilled this information, it makes it so clear that someone that don't have any background within the oil and gas upstream drilling, well engineering, could easily flow with it, and it's something that you might even want to get on the bus to join the well engineer guys. So thank you so much for that. I'm sure people have questions. I can see Mayowa Daniel, his hands is up. I'm sure you have questions, and I'm sure a couple of other people too have questions. And people might also be wondering, how do I move on from this side I am currently to the expertise side of the whole thing, which is something that will also come later on. So Mayowa, you can go ahead and ask your questions.
Okay, cost. Dexter guys, somebody asked the cost. Somebody asked about the cost, the fee for the course.
Yeah, Mayowa, your hand is up. Do you want to go ahead with your question, or you want to
No,
bring
no,
me
I
the
think
answer?
yeah, she just texted.
Yeah.
She just on the chat.
Okay.
Okay,
Sorry.
okay.
Good day, everyone. Can you hear me?
Yes, yes, we can.
Yeah, I'm Mayo by name. I'm also, what's it called, a well engineer in Desktop Pro. So recently we started using we've been on it, but I was just recently assigned to the Innova software, which I'm still getting myself familiarized with it.
Mm-hmm.
So it has been a very friendly use software so far, so good. But I had one or two challenges while using the software. So I don't know if you're there to answer my question due to your expatriate and
Yeah, yeah,
following
of
up.
course. Yeah,
Yeah,
I mean,
so
this is
I
yeah. I mean, if you can please send me the email with the challenge you are facing with the screenshots and everything, and we can organize a session to help you sort out. I also have connection with Innova subject matter experts. They do these things all the time. If you have a small question, they can fix you up really quickly. Otherwise, I will help you as well because I also use it a lot.
oh, okay. So that means there's an open check. Whenever if I can have your contact, your mail. So whenever I'm having one or two issues while planning a well, I can easily reach out to you for assistance. Is that what you're trying to say?
That's no problem. I mean,
Because
I
I
like the
currently
problem
have
solving.
I currently have a well which I just planned for
Okay.
for Desktop Pro recently, and it's still on program. I'm done with it, but I've not submitted the planned.
Yeah, yeah, I
So,
got you.
but yeah, so I made one or two. There's one or two things I observed about the software itself. Like when I was trying to bring up the 3D, there is more or
Mhm.
less like a bug or a glitch that is just like as yours was displaying perfectly. Mine, my 3D is not coming up. That's my trajectory part for my 3D view is not coming up. It's just showing a blank. So I don't know,
Yeah,
maybe it's my own administrator setup or there's something wrong somewhere which I'm
yeah.
not really getting right.
Okay,
So I
they,
made a
yeah,
complaint about the software that I think something is wrong with. You know, we
yeah.
had a recent updated version of the software, which is WellSeeker X
Yes,
instead of
right.
the WellSeeker Pro. So we
Mhm.
WellSeeker Pro is like the 2 point something version that was done, and we are currently using the 3 point something version, which is a bit is the same but a bit different. So I don't know if it's the update that is affecting
Yeah.
the design I'm doing or something else is going on with it. And I also noticed one or two things during your design when you are importing your trajectory to the well engineering. So I discovered what you just did is you went to take all the data
Mhm.
survey as a survey data, that's the
Yeah.
breakdown data that was done, that the calculation breakdown that was done
Mhm.
from a particular planned well, you copied it and import it, and there was an automatic calculation for the survey. But when I was planning mine, all I just need was my 5 casing section. That's from the kickoff point.
Yeah, I
No, I just
know.
took from the kickoff point
Yeah,
to
yeah.
to my target, to my MD, and I calculate and get and I use that to run it. So I don't know if I'm still on track with just those 5 key casing section from the kickoff point to my target, that's to my MD, or I have to also copy all the data from beginning to
Mhm.
the end. I
Okay,
don't
this
use
is
that. What I use is
yeah,
different. So if you
yeah.
have
This
an
is the
explanation to
yeah,
that, you can come up with it.
yeah. You can copy only 3 lines, and the software will be calculating in the same way. I opted to use the longer version because what you do in the planning modeling is impose the tortuosity on the top.
Okay.
You impose the tortuosity in your modeling deliberately because no hole is gun barrel hole. It's a tortuous path. You want to mimic the zigzaggy pattern of your trajectory. That's why I wanted to give the software longer version and impose the tortuosity on the top. I can
Okay.
explain it
Okay.
a bit more. Yeah, but I have got
Oh,
a guy for Wellseeker X, the new version. We have a gentleman called Jay. He is the
I know
British
Jay. I know Jay.
expert gentleman. He can fix you up because they do this all the time, these kind of questions. So please send me your question on my email, naeem@oxfordwellengineering.com. and I will sort you out with him.
Okay. Thank you so much, Naeem, for that quick response. Mayo, also, you can send, you can catch up with Naeem after this session. I can see Engineer Oche hands up. So we'll take that before moving on to other details. Please go ahead, Oche.
Good evening, Mr. Naim and every other person on the call. I must say the session has been quite informative, especially with respect to optimization and cost saving. I've gathered a couple of information that is quite useful to me on that. But Mr. Naim, just quickly, I want to ask, with the Innova software, during web planning, does it say if your trajectory is optimized for, say, slick line runs and the coil tubing runs, just to avoid certain challenges when carry out your slick line runs during well completion? Yeah. So does the Innova software tell you your trajectory is well optimized for that? Thank you.
Yeah, we can do. Okay, it's a very good question, because a lot of time when they are in early days of drilling, they would like to have a wire line to be able to run all the way to TD. In order to achieve it, you don't want your wells to have more than 60-degree inclination. If it is less than 60, let's say 55, you should be able to run wireline. And for the coil tubing, you can do the modeling. Actually, instead of having a string, you can have a tubing of 2-inch, and to see how far can you go with it, and plan accordingly. Go back to your plan and change it until you can run this 2-inch coil tubing all the way to the TD. So you can actually take it as a constraint on your well plan shape. You can say, okay, I will not go above 60-degree because our guys want to run wireline. This is standard, by the way. Most of the well that people wanted to run wireline, they never go above 55, 60 degrees for their well planning. And with the coil tubing, it's slightly different, because a different coil tubing has different buckling threshold, and you need to do the interactive exercise. You will have a 30-degree well and see if you can coil tubing all the way to the TD. If yes, you can go 40 degrees, and try to find the place where you are okay with some margin of safety. Okay.
Okay, so thank you, Oche. I'm sure your question is answered. Do we still have any other questions?
Yeah, I have a question also too, which is also one of my concern. What's going on with the casing design with the engineering tool itself?
It does not have the casing design in it just now. I have asked that same question. For developmental wells, they have already done the casing design. So most of the developmental part where they are drilling a lot of wells, they already have the casing design done and confirmed. They don't have to change anything in most of those wells. But I think it's a good question, and they may incorporate the casing design maybe in some other module.
Okay, because it is one of the concern currently now.
Yeah.
Recently,
Yeah.
we were listening out the software to a particular complaint, and when you are comparing, maybe for instance, you're using Landmark or Compass, and one of the features they do is to compare the flexibility and the functionality of these two softwares. You check the price, the cost, and also check the functionality of it. And if casing design is also is a very important completion process in well drilling, and if it's missing and you have to be looking for other means, other software to get this done. So it also is like a barrier that need a mitigation for it to be successful. So it's also a very great concern to me whenever there's a job concerning that we have to be opting for something else. So I hope if the casing design can be functional as soon as possible.
They have been very successful. Innova people, I was told they have 3,000 licenses from all around the world. With this new package they have a lot of good report from younger drilling engineers, because it's more sophisticated. What I have not shown you today is their web portal. They also have well engineering web portal for actively drilling. The data is coming in and doing the real-time calibration, which is actually takes longer time for me to explain and run through, but maybe that is also great. Okay, Tawheed,
Okay.
please.
Okay.
Okay, we are behind schedule. Okay, Tawhid. Okay, let's give opportunity to Tawhid. Tawhid, please go ahead and ask your question before we wrap up.
Good evening. Thank you very much for that wonderful section. So basically, I have 3 questions. For we, an early career well engineer who is interested in well planning and well initiation and well design. Firstly, how can we get the recording so that we can watch better and understand? 2, is it possible we also get your PowerPoints? And 3, which of these softwares are available for us as an early career well engineer to lay our hands on so as to get the concept of web planning and web design? Which of it is available online that we can download that is free? Thank you very much.
Yeah, Raglan, you can talk. I
Okay,
think it's a question for Dexter.
So, Tawhid, thank you so much for that question. So, first, this masterclass is recorded. So that means if you are in a group, it will be shared so that you can catch up with anything that you missed out. Okay. Now, aside that, there is a follow-up class or full session where if you are really interested in this and you want to learn and you want to move from the point of A, being an early career or somebody that just want to step into that career path, to being an expert that can, design well, use this software. There's a class that we will be dropping the details very, very soon. And if you are in the group, you get the full details about the class, the cost, how you can make use of this innovative software. Naeem covered in part of the session that you're going to have a long access to the software, so you can practice and do a couple of things with it. So, and the full classes itself will be recorded. In fact, all our classes, all our sessions in Dexter Pro recorded, because we know that sometimes your timing might not work with the schedules of the class. So this is opportunity for you to revisit, the recording. And apart from that, joining the main class itself gives you opportunity to, you have the himself. This means if you have any question, not just within the class, even post the class, you can always reach out and your questions will be answered. So no issues. If you are in the group, we'll share details about this recording, and then how you can participate in the full class to get you, up to speed to start running, even as you pick up your career in, well engineering. I hope that answers your question, Sarah. Are you there, Sarah? Okay. You're on hold, Tariq. So I want to believe that is answered. And if you are in a group, the WhatsApp group, you will still get more details about all of that. So at this point, we are behind schedule, and I'm sure there's no other questions. So if you are in our WhatsApp group, we'll share the details about the main class, the main course itself. We share the details about how it's going to run, because we have decided to make it very flexible. So that you want to do a straight class, or you want it to be broken down. So all of those details will come, and then the total cost of that class will also be covered. So we want to remain, encourage you, if you are in the group, please remain there. Before Monday, you get details about all of this. And if you are yet to join the group, please, Florence is going to post a link to join the group again in case you have not joined, or you have a colleague that you would like to invite. Please get them to join us, and then we'll share details about the full training itself. Thank you so much, everyone. Thank you so much again, Naeem. It's been a pleasure having you around, walk us through this. And I'm sure that this is just the tip of iceberg. The main class itself, I'm sure it will be loaded, and I don't want to see any one of us here miss out on that. So over to you, Henry, please, if you are there. Henry?
I don't think Henry is here, but
Okay. Florence, please, can you, okay, you share the, yeah. So if you are here to join the group, WhatsApp group link is shared in the comment section. please you can join our group and then you get details for other things. Okay. So at this point, I don't think there's any reason to keep us waiting again. Florence, you can bring this to a close and you know, I will take it off from there on the group.
Yeah, can I say something? Yeah, just as well about
Okay,
yeah
please go ahead.
about learning these kind of practical courses. The main benefit, the way that you conduct in the interview will be really strong, because you have been there, you have spent time with the analysis, you have a kind of depth and breadth of a proper professional. It is like mimicking that you are already got the job, basically as a drilling engineer, if you do it properly. Because we have delivered this topic in a slow drip teaching method, where we teach this 90-minute lesson and then meet up after 2 days or 3 days. Every session will be kind of with practical projects when people can actually spend time doing, but not just that you feel confident. You will also be effective. You will be doing the kind of job that you wanted to get when the time comes for having a chat with someone, a senior engineer or something. They will feel what you know and how much investment it would be for you to. So I think they are not interested to invest any resources on training. So that could position you nicely among so many other gentlemen who are also very talented and very capable, but you will have a slightly more edge on the top of it because of being there, doing it, dealt with issues, solved the issues, stuff like that,
Yeah,
Yeah,
you're
thank you
right.
so much for that addition. Yes, yes, yes. So I'm sure the audience they understand everything. Okay, go ahead, Florence.
Yeah, I just wanted to say the final thanks. Thank you, Mr. Naeem. Thank you so much for
Yes.
an insightful session. We learned a lot, and this is a class that doesn't come so often. Is a one of a kind class, and I'm so sure everyone here can agree. It was very insightful. We really thank you for that. Thank you, Mr. Rigland, for handling the class so far. And on that note, we'll have to end the call. And as we said, if you have not joined our community, please join our community. And also you can follow our socials on both Instagram and also on LinkedIn. We're very effective there. Dexter Pro Limited and also Dexter Pro Academy, because we post a whole lot there. We post our updates and other insights that you will definitely find valuable. Okay, thank you very much, everyone, and do have a lovely evening.
Okay, thank
Yeah.
you very much. Okay, cheers. Bye bye. Have a nice one.